Hello, and welcome to today's webinar. It's time to rethink mine water management, brought to you by Pit & Quarry Magazine and our sponsor of the event, Xylem. I'm Allison Barwatz from North Coast Media, Senior Digital Media Manager for Pit & Quarry, and I will be the producer for today's event. Before we get started, I want to let you know that today's webinar will be recorded. You are currently in a listen-only mode. A recording of this webinar will be posted to pitandquarry.com/webinars and will also be emailed to you tomorrow. At this time, I'd like to acquaint with you the ways in which you can participate during today's presentation. Please notice the Q&A panel to the left side of your console. If you have a question, type it in the panel's text box, then click Submit to place your question in the queue. We encourage you to ask and enter any questions you may have for our speakers during the presentation. We will address these questions at the end of the presentation during the Q&A portion. Questions submitted during registration have already gone to our panelists and may be covered during the presentation. If you experience any technical difficulties during today's event, you may use the same Q&A panel on your screen to submit your issue, and assistant producer Kelly Limpert or I will personally assist you. You may learn more about our speakers by viewing their photos, bios, and email addresses in the panel located in the upper left-hand corner of your console. You may also learn more about today's sponsor, Xylem, at the box in the top right-hand corner of your console. If you are logged into your social media accounts, you can share the webinar's title, description, and URL with your friends or colleagues using the Share This widget. Now, I'd like to pass it over to our moderator, Mackenzie Schoner, to introduce the speakers for today's webinar. Mackenzie, take it away.
Thank you, Allison, and welcome everyone to our webinar. It's time to rethink mine water management. Today, we will be hearing from Jesse Parmar, Business Development Manager for the Industrial Marketing Team at Xylem. Throughout the years with Xylem, Jesse traveled throughout Canada working with mining end users to solve challenging pumping issues, but in recent years has shifted his attention towards working with these end users and others throughout North America on an overall fluid management approach. We will also be hearing from Stephen Rothwell, Director of Strategy and Marketing for Xylem's Assessment Services Division. Prior to his current position, Stephen worked in strategy for Xylem's Digital Solutions team, focusing on the implementation of organizational processes and the acquisition and integration of new businesses into the platform. And also from Matt Previtt, Services Business Development Manager with YSI's Integrated Systems and Services, a division of Xylem. Matt has served with YSI for nearly 20 years in various roles, from sales to project management, working directly with customers to provide solutions for their research, compliance, and operational requirements. Now I'll turn it over to Jesse to tell us more about mine water management. Jesse, take it away.
Thank you, Mackenzie. As Mackenzie said, my name is Jesse Parmar. I'm the Business Development Manager for the Industrial Marketing Team. I'd like to take the opportunity to thank each and every one of you for joining us on this webinar before I begin. So without further ado, let's dive right in. So as the title states, no two mines are the same, so you can't really use a one-size-fits-all approach. However, one commonality is the challenges that each of these mines face. On the left-hand side, you're going to see three water droplets. These droplets are the three challenges that I'm going to go over. So the first one is water quality and scarcity. Second one is operational continuity and efficiency. And the third is regulatory compliance. So water quality and scarcity. Water is not as abundant as it once was. The amount that you're using within your process to extract or mine for a commodity significantly outweighs the byproduct. So as a result, the cost of doing business has gone up significantly. So end users are now exploring methods such as recycling and reusing of processed water. Operational continuity and efficiency, for me, it's more of a question of uptime versus downtime. So as mentioned, as the cost of doing business goes up, it's crucial that your operation runs smoothly. And to ensure that it does, selecting the right equipment based on efficiency and following routine maintenance ensures that you receive that continuity that you're after. And then finally, regulatory compliance. With more and more pressure from lobby groups and just the overall desire for one to preserve the earth, when you're going about your processes, it's important to have the right technology in place to measure discharge levels and rates and make sure all processes comply. And now I'm going to turn it over to Allison for a poll question. Allison?
All right, thanks, Jesse. Our first poll is, what is your most pressing water-related issue on site? Water access, contamination of water, or growing cost of water and sustainable water management? You'll have 30 seconds to answer this question. Thank you, everybody, and here are the results.
Thank you, Allison. So, what is water management? So this slide here illustrates how we at Xylem go about water and fluid management and approach mining from an overall perspective rather than a specific processes. So we've broken down water management within mining in 9 different processes as seen on the right-hand side. So the next 9 slides, we're going to go into these and take a deeper dive. So we'll start with source water, make our way to water boosting. From there, turn our attention to dewatering, then process water, dust suppression, fire protection, and then we'll turn it over to Stephen to go over pipeline inspection, and then he'll turn it to Matt for environmental monitoring, and then I'll close it off with wastewater and reuse. All right, source water. I'm not going to go into this too much. As the slide states, it refers to the process of obtaining water from various sources, and these various sources are listed on the slide as you see here. In my opinion, in this process, this is where you're going to have the broadest options for pump technologies to consider using. Some of the factors to consider when you're trying to select your pump technology here is going to be accessibility of the equipment, efficiency, pumping capabilities, installation, and if you're sourcing from a body of water, the solids handling capabilities. All right, water boosting. So as the name implies, it refers to the lift or overcoming of an elevation. Given that the key here is elevation, one needs to be sure that the pump selected for the job has the ability to overcome the elevation in question. The image to the right, as you see on the image to the right, we have featured 2 different pump technologies. Both are capable, high head capability pumps. However, they differ slightly. So one is an electric submersible pump, and the other is a diesel-driven unit. So the biggest factor that separates the 2 is the power source. So if you're running your mine operations and you're limited with power, you may want to consider using an electric submersible pump when comparing these 2 technologies. And another advantage with this electric submersible pump is the sheer size of it. So you can move it from process to process, which is advantageous on mines. If that's not the case, then you could always consider using a diesel-driven unit. All right, now dewatering. So what I wanted to drive home here on this slide is that there's 2 different types of dewatering processes, one being open pit and the other being underground. So open pit mining refers to lowering of the water table, while underground refers to the process of keeping water out beneath the surface. So you see that with the image on the right-hand side. So among the 2, the biggest factor, determining factor in these 2 processes is going to be the head and flow capability. When you're encountering an underground mine, the biggest factor to consider is going to be the head, overcoming that elevation when you're passing water. When you're in an open pit mining, it's the opposite. You want to factor in and consider flow because you're going to be moving hundreds of meters from dike to dike. All right, processed water. So processed water refers to water that's not classified as being drinkable, so dirty water. And I mentioned at the beginning of the presentation that water is becoming more and more scarce as the years go by. So the cost of doing business is increasing essentially. One thing that a lot of the mines are doing now with their processed water is treating it and reusing it in processes such as dust suppression, washing, slurry transport, and others seen on the slide. Historically, when water wasn't as scarce, what they were doing with the processed water was treating it so that it could be discharged. All right, dust suppression. Dust suppression is a key process within the water management cycle, and I perceive it as being a means of environmental monitoring, if you may. The focus on the slide, as the slide states, is the process of protecting the environment, keeping the equipment clean, and maintaining one's health by reducing airborne pathogens. All right, fire protection. So fire protection is fundamental, and it's not just fundamental in mining, it's fundamental in any process and subvertical that you're going to look into. In addition to what's required in such a process, it is important to know, depending on whether your process is permanent or temporary. That's the biggest thing to take out here. For permanent installs, NFPA standards apply, so it's very strict standards, and that's referred to as National Fire Protection Association. And then for temporary systems, you don't typically see as strict standards being applied. And as a matter of fact, you're going to be seeing a lot of self-priming systems being utilized as temporary fire protection means because of their high head jetting capabilities. And now I'm going to turn it over to Stephen to go over pipeline inspection. Stephen?
Thanks, Jesse. Hi, everybody, and thanks for joining today, as Jesse mentioned initially. I'm going to talk a bit today about the importance of pipeline inspection within mining operations. And a little bit later, I'm going to provide a case study of one of Xylem's inspection solutions that was applied in a mine. I think the key thing to take from this slide is that in any mining operation, if there's a pressure pipeline that supports it, these pipelines typically will deteriorate over time due to a number of factors, and ultimately they're at risk of leaking or failing, which can cause obviously environmental concerns, compliance concerns, and ultimately downtime for the mine, which is never good. Well, the key thing I'll focus on today is leaks, and the thing to remember with leaks is that they typically develop slowly over time and don't necessarily catastrophically fail. And because of the nature of pipelines, these things might not be noticed right away, so you could have a leaking pipeline for even a period of years before you even realize that that's happening. And I'll just try and illustrate this with a quick example. One of the mines that I'm aware of here, it's called Anglo-American, and it owned and operated a 530-kilometer iron ore pipeline in Brazil, which leaked twice in a short time span. So in the first incident, 318 tons of mining material was leaked into a stream, and on the second leak, which occurred just a couple of weeks later, 674 tons of iron ore with 174 tons of that spilled into a nearby river, and what the result of this was a major fine of over $20 million for by the governing agency, and it actually threatened the ability of the mine operator to extend the pipeline due to a loss of reputation. So I think what's important here is that if you do have this type of pipeline that's supporting the mine, it's important to proactively look for problems on it and make sure that the integrity of the pipeline is intact and it continues to support the operation. At this point, I'm going to pass it back to Allison, who's going to launch a poll question for us.
All right, thanks so much. And here is our second poll question. What material in diameter are the pipelines in your operation? Metallic or concrete and less than 12 inches in diameter, metallic or concrete and greater than 12 inches in diameter, HDPE and less than 12 inches in diameter, HDPE and greater than 12 inches in diameter, or I don't know the material or diameter. You'll have 30 seconds. Thank you everyone for participating, and here are the responses.
Okay, very interesting. And I think one of the reasons that we were curious about this is that depending on the size and diameter and the material of the pipe, there are different types of solutions that are applicable for checking the integrity. You know, typically plastic pipes have got different solutions, obviously, than metallic or concrete. So very interesting results here that we have about 60% of the respondents with HDPE pipe that's less than 12 inches in diameter. And with that, I'm going to pass it over to Matt.
All right, thanks, Stephen. Good day, everybody. Stephen's pipeline monitoring is actually a bit of a good segue because I'm going to talk about an overview on the value of modernizing remote environmental monitoring on mining properties. With stricter permit regulations and increasing expectation for social responsibility these days, environmental water monitoring has become a more critical priority for the mining operators. Water management on mines presents health and safety challenges as well as operational challenges for containing or eventually discharging the treated waters off the property within required compliance regulations. Manual sampling periodically for water quality and flow and level and bathymetry in remote locations around the mine is really common, but it can be resource intensive and costly, and it carries some inherent safety risks when putting staff near open water or especially on a boat. However, remote continuous monitoring of these parameters with real-time telemetry reduces safety risk for the field staff. It can free up daily manpower requirements, and it reduces the lag time between an illicit discharge event itself and the operator's ability to take corrective action. And in some cases, it can even help predict and warn of a pending event, such as increasing conductivity or turbidity concentrations, for instance. Autonomous monitoring can also provide new ways to understand the dynamics of the water. For instance, you see the graphic on the right shows our water quality profiler, which is helping the mining scientists to monitor pond stratification and understand settling rates and conditions that lead to pond turnover, which can potentially also lead to odor problems and resuspension of solids. Those bands of colors on the side there represent varying concentrations of whatever parameter is being measured. And real-time data systems can also reduce compliance risks with alarms or even be coupled with automation systems to initiate treatment, can turn off pumps or even divert water from discharge points to holding basins. Not only does this reduce illicit discharge events and duration, it can also lead to cost savings from overall efficiency gains in water management. And I also think it's important to note that continuous monitoring provides a backup record for your discharge history. You can substantiate compliance reporting and defend against potential legal action. Plus, it also demonstrates a plant's good faith efforts towards a strong environmental stewardship. So now it's time for another polling question. Allison?
All right, thanks, Matt. Here's our next poll. What environmental monitoring needs do you have for your compliance or operational requirements? Check all that apply. Water quality, open water or outfall, meteorological, flow monitoring, open channel or outfall, pond level or bathymetric surveys, or none of these. You'll have 30 seconds. All right, thank you everybody, and here are the results.
Okay, so it's a pretty decent balance, more or less what I expect with the water quality and the outfalls, and the flow monitoring was actually a little bit of a surprise for being that high. So that's really interesting. That's good feedback. So Jesse, we'll turn this back over to you now. Thanks, everybody.
Thank you, Matt. So the last process within the fluid and water management cycle is wastewater and reuse. And the key here that I want to focus in on is reuse and treatment. As mentioned earlier, there's a growing cost to do business. And as water is becoming more and more depleted, mines are yielding less commodity within their processes. So the only way to truly maximize is by leveraging treatment. Here's what you gain by doing so. One is operational efficiency. By having a greater understanding and going about mining from an overall water and fluid management process, you have a greater overall control when it comes to these vital resources. And then by recycling and reusing resources, such as water, we are contributing less to the depletion of that resource. And then in turn, by recycling and treating, we are also discharging significantly safer, which then will reduce the environmental impact. So holistically, in turn, resulting in a more cost-effective approach. All right. In summary, in order to have effective water management, selecting the right pump, having reliable piping, and having a control system to gain more visibility in your operation is fundamental. And now I'm going to pass it over to Allison for a poll question.
Thanks, Jesse. And here's our next poll question. What would you say is your single most underlying constraint on site? Capital expenditure, inventory quality and reliability, or system uptime? You'll have 30 seconds. Thank you, everyone, and here are the results.
Excellent. Thank you, Allison. It's interesting. It's even across the board between capital expenditure, inventory quality and reliability, and system uptime. So we're going to go over all of this in the next couple of slides. So in this slide, I want you to really just remember these questions as we continue on with this presentation. So does your operation have aging machinery? Do you have a failure-prone system in place? And when you look at your equipment, is it underperforming or inefficient? All right, so let's dive into pump technology and the factors to consider when selecting the right pump. So here are 4 factors to consider when selecting the right pump. First one being operating near the best efficiency point. So the rule of thumb is that if you're operating between 50 to 125% of the best efficiency point, that's referred to as optimal pumping. Anything outside of that results in premature wear. So if you're too far to the right, it can result in cavitation. If you're too far to the left, you're going to create some high pressure, low flow, which is going to result in overheating. So it's fundamental that you select a pump that's going to be as close to the best efficiency point as possible so that you will reduce the power consumption because as you move away from the best efficiency point, your pump is working harder to try to maintain the efficiency it's designed to do so, which is going to increase your power consumption, which ultimately results in more costs associated to pumps, repairs, etc. The next point here is replacing aging equipment, and I mentioned energy consumption. One thing that you're going to see with aging equipment is there's going to be excessive amounts of wear because you've been using it day in and day out in your operations. So as your pump gains that excessive amount of wear, it's going to have to work harder to maintain the efficiency that it was designed to do so. So what's going to happen is your power consumption goes up, which costs more money for you. And then with your power consumption going up, you're running the risk of unplanned downtime associated to the pump going down. So that leads me into the third point, which is scheduled maintenance. So with scheduled maintenance, what's so fundamental about it is because it allows you to work around your shutdown schedules and maximize your uptime. There's a lot of technology out there that can help assist with scheduled maintenance, such as asset health devices. So these devices will let you know the condition of your asset and then also make suggestions on maintenance plans. Finally, optimizing via smart technology. So we already talked about asset health devices. That's one of the types of technology that you can use to optimize your process. Another one is going to be incorporating intelligent pumps. By using intelligent pumps, they're going to be working towards operating at the most efficient point, which is going to significantly reduce your energy consumption. All right. So now the factors to consider when determining the right pump. So the first one here, and we've already talked about it quite a bit in that last slide, is going to be the head and flow requirements. That contributes directly to energy savings and efficiency. So the closer you are to the best efficiency point when you're selecting the pump, the more efficient your operation is going to be, the less wear and tear you're going to have through premature wear and tear. Now the next factor to consider is going to be location. So location, I look at it as twofold. One is going to be looking at it through the perspective of classification. So you can be in a process where you need some explosion-proof equipment. So that greatly affects what sort of pump technology can be used. And then the next is going to be the physical size and where you're going to be operating. So you could be, space could be constricted. As a result, the types of pump technology to use may be limited. Third thing, and we talked about this a little bit when we were going through the 9 processes, is power limitation when we compared the electric submersible with the diesel-driven Godwin units. We have a case study later where power limitation was one of the factors worth considering. So in a case like that, we needed to use a diesel-driven unit. Next factor is controls. So a lot of the equipment that is going to be spec'd out is going to be coming with some sort of intelligent control system. Some doesn't, and as a result, that's what's going to really determine what sort of equipment you're going to use. I'm sure if you're going to select a pump that has an the intelligence built in, that's going to override one that has a basic control to it, because you're going to maximize your energy efficiency. And then solid content. This is a no-brainer. Some piece of pumping equipment can handle higher solids than others, so you're not just going to throw any sort of pump into your tailings operation. It has to be able to withstand the solids and the viscosity. And then finally, physical size. We touched on it when we went over location. If you're in an area where you're constricted diameter in a sump, an under drain, you're going to be looking towards considering a slim profile pump like an electric submersible or a vertical turbine. All right, so now we're going to go over the risks. All right. So we mentioned that it's very key that we get as close to the best efficiency point as possible. The further away you are from the best efficiency point, one of the biggest risks you're going to run into is your premature wear. Your pump has to work significantly harder to maintain the efficiency that it was designed for. So as a result, your power consumption goes up. So that's wasted power. And then with the wasted power and premature wear, it's going to result in the likelihood of unplanned downtime, which is essentially system failure. So I can't stress enough how important it is to get as close to the best efficiency point as possible. All right, so in the next 6 slides, we'll go over ways to avoid such risks. So an audit can help mitigate your risks. By doing an audit or performing an audit, you could boost overall efficiency, reduce costs, and then enhance profit margins. So now let's go over an action plan. There'll be a 4-step action plan that we're going to go over here. All right. Step 1 will be to come in and perform an audit to determine if your equipment is properly sized, determine where your operation is in relation to the best efficiency point, how critical the asset is, and in the case where it is critical, do you have a backup system or a redundant system in place? And then finally, in the instance of failure, determine the means of failure. Now, when it comes to sizing, what we've seen in the past is that most operations, when trying to save on inventory and equipment, will try to size pumps to fit all their processes, which isn't possible since it results in some pieces of equipment operating outside reasonable means of the best efficiency point. All right, step number 2, optimizing pump energy consumption. So the focus here is to get as close as possible to the best efficiency point, and I know I've said that a lot. A fundamental tool that can help you here is going to be a VFD. We talked about how operations and end users will typically try to maximize their equipment use from process to process and minimize the inventory. So one way you can do that is by using a VFD. So now you can have a couple of models rather than having 5 or 6 different models of a pump on site, and then that VFD is going to allow you to essentially toggle and get as close as possible to the best efficiency point. All right, step 3, optimize pump costs of ownership. So the focus here is going to be around reducing unplanned maintenance costs and the costs in general associated to aging infrastructure. As seen here, unplanned maintenance can cost up to 10 times as much as routine maintenance. To help control costs, you can standardize your equipment, as mentioned in the previous slide. You can utilize asset health devices or even smart pumping technology. Finally, step 4, optimizing the system. To me, this is one of the most important means of delivering efficiency, yielding more, and preserving the environment. And that's by taking a more of an overall approach rather than a process approach. So the rest of the presentation, we're going to be going over everything that we just did, but putting it into practical use with case studies. So the first case study we're going to go over is remotely operated solutions that help reach new depths. So in this process, the end user had discovered more copper in their mine, but expected access water. They wanted a solution that was remote to monitor and control, because as they got deeper, power became more difficult. So the main focus here was to pump water from further distances, in addition to the challenges listed on the slide here. So the pump switch was originally deep within the mine, so personnel had to travel deep in the well and physically handle and control the pump. So the solution that we came up with was 3 Godwin HL130 dry prime pumps. So with this diesel solution, you no longer had to worry about cables constantly being in the way. Having the operation be diesel, you can operate at the surface, so you eliminate the need for multiple junction boxes, and you address the power limitation. So to overcome remote monitoring, the team provided a custom panel that allowed the mine to remotely start and stop the pumps, monitor capacity and fuel levels, and communicate operating parameters. This was also integrated into the mine's own SCADA system. For the result, so it should be mentioned that this solution was the first time that the mine tried a surface-mounted diesel and suction solution, and it's paved the way for further installs. And also, the neighboring mines have used similar solutions as a result of it. So with this solution, they were able to save costs by eliminating labor associated with switching pumps or running electrical power down the mine. There was also the added safety of not having to go down and operate and control the pump. And it was also able to be monitored and integrated into their own SCADA system. All right, so the next case study we're going to look at is going to be Aggregates processing plant relocation. So in this project, we were challenged to help assist relocate the mine's processing plant due to increased production. The end user desired a single source provider who could design and install comprehensive integrated water management system. After completing an extensive audit, we worked closely with the mine to develop a comprehensive plan to improve operational efficiency and increase required water supply. So what we supplied was a Gould's Water Technology short set line shaft turbine, Gould's Water Technology 3756 single stage end suction pump, some Gould's ESV multi-stage pumps, 2 tanks, pipes, and fittings. So the result, the turnkey solution provided resulted in the plant's process increasing by 15%. So they were able to process 15% more aggregate. It also resulted in SCADA connectivity capabilities, which allowed for proactive monitoring controls, minimal downtime, and allowed for one person to control the system, which in turn provided operational savings for the mine. So the next case study that we're going to look at here is the vision of an autonomous mine. So in this particular project, the mine was looking to improve their dewatering process because if their underground mine held access water, production would be halted and revenue would be impacted. So what we proposed here as a prototype was the Flight IDD. So it's our new submersible pump that we're going to be releasing early next year with integrated control system built in, similar to what we have with our conservator technology with IE4 permanent magnet motors. What makes this technology so unique is with the control mechanisms built in, we no longer operate off of the theory of being trying to select a pump to be as close as possible to the best efficiency point. Because with the control mechanisms built in, the pump in each pump cycle is going to try to find the most efficient point. And then when it does, you know that it's going to drastically improve efficiency, reduce energy consumption. And then with having an operation as such, your inventory will be reduced as well. So the results. So for this particular mine, we saw was 30% reduction in inventory. We no longer had to worry about different impeller trims or components because this pump was able to operate at the most efficient point in different duty conditions. And then by operating at the most efficient point, energy consumption now went down. So for this mine, there was energy savings up to 60%. And then having the adaptive speed capability and preventing the pump from running dry, you prevent and drastically reduce the amount of wear that the pump's going to take. And for this particular case study, it was up to 70%. So now I'm going to turn it over to Stephen to go over pipeline inspection. Stephen?
Thanks, Jesse. I'm going to give a quick case study now highlighting Xylem's inspection applications for mining operations. In the case that I have up here on the screen, the owner of this mine operated two 20-year-old parallel plastic pipelines that were 12 and 14 inches in diameter and ran for about 3 miles. Both of these pipelines were regulated by the Environmental Protection Agency and were of really high importance to this owner because they were very close to an environmentally sensitive water crossing, which you can see in the picture on the right. So anytime you're inspecting a pipeline, especially one that supports a critical operation, there's a couple of big challenges to remember. The first is how do you keep the pipeline in service to reduce the amount of downtime that you have? The second, especially when you're dealing with smaller pipe diameters, in this case 12 and 14 inches, is that you're typically looking for a small leak that's not going to be visible if you're just walking over the pipeline. And how do you locate that leak along a pretty significant stretch over 3 miles? So one thing to remember is that based on the pipe material, which we polled earlier, a leak is going to develop differently based on that pipe material. So in this case, the plastic pipes were the ones used in this operation. And for this type of pipe, you're typically going to see a leak at the joints between two pipe sections. And this is usually due to improper installation of the joint or any type of ground shifting, which is what they were concerned about in this case because of the environment that the pipeline ran through. So you're not going to typically find a leak on the barrel of a plastic pipe as a crack or a hole in the pipe because it's just not how that pipe leaks. So that means that your pipe is not going to completely fail. It's often going to be a small leak that develops over time. So to complete this inspection, Xylem used the Smart Ball tool, and that's a free-flowing tool that operates while the pipeline is in service. So there's no disruption to the operation, and it travels with the product flow from where you launch it to the end point of the inspection. And how it identifies leaks is that it has an acoustic sensor on board that essentially listens for the sound of the product that's being transported leaving that pipeline. So as the product leaves, the tool will pick up that sound of the product leaving, and because the tool is actually passing that leak location directly, we can actually see a very unique acoustic signature that shows you the leak as it's approaching, and then it goes away as you move away from it. So because it's passing this leak directly, it's very sensitive and able to find leaks that are about 0.03 gallons per minute or larger. And just to put this in perspective, that's typically, let's say the minimum threshold is about 2 jugs of milk per hour. So it's a pretty small amount of product. And just moving on to the results. So this inspection, again, was completed over 2 days, one for each section of the pipeline. And what we were able to find was that there was one medium-sized leak, which was about 6.5 gallons per minute, so a little bit larger, that was actually quite near to the sensitive creek area. And this allowed the operator to do some targeted repairs on this line rather than shut this whole thing down to inspect it. And it basically avoided a compliance violation and led them to the decision that they should probably be doing this type of inspection more regularly on their pipelines. And with that, I'm going to pass it back to Matt for a case study.
Thank you, Stephen. Based on the poll results, I wish I had focused on a water quality and flow monitoring example, since that was what most everybody was most interested in. Rest assured, we do have products that address all of that very well. It's our forte. But I wanted to mix it up a little bit and provide an example of a different type of application instead of the continuous monitoring. So, because one of the challenges the mining operators face is that they need information for planning purposes in regards to their ponds and lakes. They need to know how sediments are settling, whether it's piling up unevenly or in places they don't want near things like aerators, pump intakes, or discharge structures. So in this example, the customer needed to determine the deepest location in the pond so they could move an intake pump so it was more efficient. They also wanted to know how much holding capacity they had available in their ponds for excess water and for additional tailings, meaning how much time did they have left before the pond was going to fill up. And to do this normally, conduct a bathymetric survey normally would traditionally involve total station positioning and soundings taken from a boat on the pond. But the problem is that this can be dangerous and difficult to accomplish at some mines. The area around the pond may make it difficult to launch a boat, for instance. In a couple of projects we've done, we found quicksand-like muck all around the pond, making it difficult to approach with the boat. On top of the boat launch challenge, though, surveying on the water can be labor-intensive and sometimes requires 4 or more people in order to comply with the safety standards. And of course, it can be risky working on waterways, especially if it's one of the more caustic type ponds. In this case, it was primarily that the sides were too steep to get a boat and people on the water easily. So our Xylem solution was to provide the service to conduct the bathymetric survey for them with our RQ-Pod radio control vessel, our Sontec hydrosurvey, our M9, and our HYPACK processing software. You can see the little boat in some of those pictures on the bottom. It's just like the size of a boogie board. The M9 is an acoustic Doppler sensor that we originally designed to measure flow in rivers and streams, but it also defines the distance to bottom during those measurements. So it was pretty easy to firmware change to optimize it for bathymetric surveys. Essentially, we're using the 9 beams like multiple echo sounders, which are angled out to measure more than just directly below the boat. Therefore, we are measuring more of the bottom during each pass, which reduces uncertainty in the assessment and allows for fewer passes, which ultimately means less time required. However, while the acoustic technology is great, it's the integration with the remote control, RQ-Pod, and HYPACK software that address the safety and operational challenges for the client with fewer staff and less time than a traditional survey would have taken. I know the slide here shows 4 people in the picture, but the reality is we only needed 1 or 2 people. The rest are just observing. And nobody had to get on the water. And the vehicle was driven according to a mission plan in the software to conduct the necessary survey, and we were then able to provide the customer with a bathymetric model they could use to calculate pond holding capacities and the pump placement itself. Here's an example of a model generated from data collected with our system. You can see the low-lying spots in this pond. And you also get raw data, which can then be used in whatever way to do more calculations. I also just want to quickly mention we have 2 other vehicles that are used similarly in these mining studies, EcoMapper and the HiCat. And those vehicles can be programmed to operate autonomously, so the operator doesn't even have to steer it during the survey. And then those instruments also have additional sensors for measuring water quality and mapping, as well as side scan imagery for objects on the bottom if you're looking for something. Yeah, so that's it. So I hope I was able to present you with some new ideas to consider for automating your environmental monitoring, and I look forward to hearing your questions later today or in the future. Thanks again for your time, and back to you, Jesse.
Thank you, Matt. All right, so now let's take a brief moment to summarize what we've gone through. So the key takeaway, as you would have heard me mention throughout the presentation, is to take a holistic approach and an approach from the perspective of being a solution provider and not a product provider. By doing so, the whole water management process becomes more efficient, sustainable, and safe. So if any of you are interested in a free mine audit, our contact information will be posted, and we'd be sure to direct you to the right representative in your region. So I wanted to take a brief second here to highlight some of the brands and overall capabilities that Xylem has to offer. As you can see, we have various pump technologies, package systems, heat transfer equipment, treatment solutions, monitoring systems, analytics, and many more. So in addition to being able to provide, a solutions provider for all your permanent needs, we also offer rental solution for all your equipment in instances where there's a need for temporary solutions or where you may be capital constrained. So I'm going to turn it over to Allison for our final poll question. Allison?
All right, thanks. Here is our final poll question, everybody. Would you like to conduct a mine audit at your site? Yes or no? You'll have 30 seconds to answer this question. Thanks for your responses, everybody. And now it's time to turn this back to Mackenzie for today's Q&A period.
Thanks, Allison. Let's dive in. For our first question, what advice do you have for dewatering during winter months?
I can take that question. So it's going to really depend on what region you're in. I operate out of Canada, but as mentioned at the start, I overlook America's commercial team. Biggest things for me and my suggestions are going to obviously be routine maintenance, which regardless of whether it's winter, summer, whatever season, that's key. If you have a control, weatherproof enclosures are going to be fundamental. If you're dealing with diesel-driven units, block heaters for your engines. With submersible pumping technologies, it's always key to make sure that it's completely submerged to prevent any sort of freezing of the impellers. And then if you have any sort of open pit dewatering in the winter months, it's always fundamental to consider some sort of mixing apparatus to generate thrust so that it generates heat and prevents that pond from freezing over. Those are the suggestions that I would make.
Great. For our next question, when selecting the appropriate analytics products to use for pipeline inspection, what factors would you consider or what information would you as a manufacturer need?
Sure, I can take that one. I think the most, and this kind of aligns with the poll results we saw earlier, the most important thing for us to consider is the size or diameter of the pipeline and the material that makes up the pipeline. And that's primarily because you'll have different solutions available for different pipe materials. I would say that another key thing to know, particularly if you're considering an inline inspection of that pipeline, is the flow rate that you can either have as a minimum and a maximum, because tools that are inserted into a live pipeline need to be controlled using the flow rate. You also want to consider if there are logical kind of insertion or extraction points for tools. And then something specific to the, I think it was around 40% of people who said they had metallic pipe, is what other protective measures are currently installed on that pipeline to protect it from degradation. So there are things like pipeline coating and cathodic protection that would typically be seen on a metallic line, and the presence or absence of those would help dictate, what types of solutions are available.
Okay, next question. What factors would you consider when trying to reduce operating cost and improve dewatering efficiency?
I can take that question. So to reduce operating costs and improve efficiency, we went over this quite a bit in the presentation. One thing is going to be proximity to the best efficiency point. As stated, the closer you are to the best efficiency point, the more efficient your operation is going to be, less power consumption, which directly affects operating costs. Another thing is going to be replacing your aging infrastructure. When you have aging infrastructure, you're going to have wear on your equipment. So when that equipment is going to be operating, it's going to be working significantly harder to try to maintain that efficiency it was designed to perform at. So then your energy consumption costs are going to go up. Other things that I would recommend considering is going to be something like an asset health device or have some sort of scheduled maintenance plan in place, because it allows you to optimize based on your shutdowns, and then you maximize your uptime, and you're not going to have to worry about unplanned downtime associated to a piece of equipment going down, because the costs of a repair or replacement of a piece of equipment do not outweigh what downtime associated to your process and your operation is.
Okay. For our next question, is there specific parameters or solid contents that your environmental monitoring devices can be used in, and are they geared towards water management and everything to do with water?
Yeah, this is Matt. I'll take that one. Yeah, I mean, our equipment is designed to measure water in a variety of ways and applications. And so I think that when you're getting into the higher solid content, more on the process side of the system, we have a certain type of product or brands of products that suit that application. They're typically more industrial and run off of land power. And then as you get further away from that and you get closer to your discharge point, we start to have equipment that is more suited to that remote monitoring, a little bit cleaner water or less thick, if you will. We run off of batteries, solar panels, and we have remote telemetry to get it into SCADA systems and the like. So yeah, our equipment covers a wide gamut of applications like that. We do the water quality, do the flow monitoring, do some controls as well. So yeah, when it comes to water management, I think we covered just about everything, especially when it comes to environmental monitoring aspects.
Okay. What factors in on extended service life and reduced repair cost?
I can take that question. So the factors to consider to extend service life and reduce repair costs, one, and again, I hate to keep mentioning it, is by selecting the right pump and making sure that your duty point is in line with the best efficiency point is going to be one, because the further away you are from the best efficiency point, the greater the likelihood of premature wear. So you'll significantly reduce repair costs associated to that. Having a planned maintenance schedule in your process is always fundamental as well. Again, it's going to go back to the fact that you will then schedule your maintenance around shutdown, and then you're maximizing your uptime. And then just having that routine maintenance is always key as well, because then when it comes down to, if you're not going to be routinely checking your equipment, you're going to greater increase the wear, which is then also going to increase the repair costs associated to your equipment.
All right, and for our last question, is there a cost associated to your audit?
I can take that one. No, these audits are free.
Okay, great. Thank you all so much for discussing why it's time to rethink mine water management. As we wrap up, I'd like to thank everyone for attending, and I'm going to hand it over to Allison for some closing remarks. Allison?
Thanks so much, Mackenzie, and thanks to our presenters for their insightful presentation. I hope you all enjoyed today's webinar. It's time to rethink mine water management, brought to you by Pit and Quarry Magazine and our event sponsor, Xylem. If you have any additional questions for our speakers, you can reach out directly via the email addresses you see on the slide now. The PDF version of today's slides are available via the resources panel on the right side of your console. A recording of this webinar will be emailed to you tomorrow and posted to pitandquarry.com/webinars. Upcoming webinars from Pit and Quarry will also be posted to that page. Once this webinar ends, please take a few moments to respond to our feedback survey. Thank you all for attending, and we hope you'll join us for another great webinar.